In this video we're going to discuss how to properly answer the exam questions to make sure you get all the marks you should get for the question. We're going to discuss question 6 in assignment 3, which is just a basic calculus optimization problem. We start with the function f of x is equal to 2x to the fourth minus 8x squared plus 6. Now the first question asks us to determine the stationary point of the function. Now we know that to determine the stationary point we simply first get the derivative, which is 8x squared minus 16x. 8x to the third minus 16x. This fortunately factorizes quite easily, and we get 8x times x minus square root of 2 x plus square root of 2, and we can come to the conclusion that the derivative is equal to 0 whenever x is equal to 0 or x is equal to minus square root of 2 or x is equal to square root of 2. Now you shouldn't stop your question here. There's a lot still left to do. In fact, if this question counted 6 marks at this point, you would only have earned 2 of those 6 marks. The things we need is we need to classify whether these points are maxima or minima and still find their function values. Now the function values are easy to find. We first get f of 0, which is 6, f of minus square root of 2, it's easy to substitute in the squares, take care of all the square roots, and we get minus 2, and the same thing, because this is an even function which gives the same output on minus x as x, f of square root of 2 is the same as f of square root of minus 2, and that is also minus 2. Now we need to classify these points as maxima or minima. So for that we need to take the second derivative, which is 24x squared minus 16. Substituting the values in, we see that f double prime of 0 is minus 16. So we know we have a maximum. F double prime of minus square root of 2 is equal to 32, so we have a minimum, and f double prime square root of 2 is again equal to 32. So now we can come to our conclusion that we have minima at minus square root of 2, and then you add the function value and square root of 2 and the function value, and you have a maximum at 0 and function value of 6. And that is the way you get full marks for this question. You not only solve the x values of the stationary points, you find the y values and classify whether they are maxima or minima. Now the second part of the question asks you to find the inflection points of the function. Now we know the first way to look for inflection points is to set the second derivative equal to 0. And in this case the second derivative is 24x squared minus 16. Set that equal to 0 and solve. If we simplify it a little, it gives us 3x squared minus 2 is equal to 0, and that gives us x equal to plus or minus 2 divided by 3, square root of. Now again, we can't stop here. We also have to get the function values, and we have to find out whether these are in fact inflection points. Remember that the inflection points are where the curvature of the function changes sign. So it's in fact where your second derivative changes sign. So let's just first finish this off and look at the function values we have here. F of square root of 2 over 3. Again, this is if you substitute this into the original equation for the function f, it's something like this. That's minus 8 times 2 over 3 plus 6 is equal to 8 over 9 minus 48 over 9 plus 54 over 9, which is 14 over 9. Now again, as I said, this is an even function, so it doesn't matter if we have a positive or a negative x. The result is the same, so we have two function values here. Now, usually I will accept this much as correct for classifying the inflection points. However, we have to make sure that the function f double prime x, the second derivative, in fact does change sign at that point. And that is actually easy enough to see because our second derivative is just a parabola which is symmetric about the origin and therefore quite easy to draw. It'll look like this, with one root at minus square root 2 over 3 and one root plus square root 2 over 3. So we can see clearly at these points the second derivative changes sign. Now we can conclude that we have inflection points at minus square root 2 over 3, 14 over 9, and square root 2 over 3, 14 over 9. And that completely answers the question now of where are the inflection points of this function. Now the last question, the last part of the question asks us to determine where f is convex and concave. And unfortunately, we've already done most of the hard lifting for this question. So we know the function is convex where the second derivative is greater or equal than 0. Now we can just actually look at the graph we have here of the second derivative. We can see easily that it is larger than or equal to 0 on these two bits at the beginning and the end of the region under consideration. So we can see that x smaller than or equal to minus 2 over 3 square root, or x greater or equal than square root 2 over 3. So we can conclude that f is convex where on the intervals, now it's not necessary to write this in interval format, you can keep it as x smaller than equal to, x larger than equal to, but I do like writing it this way as a subset of the real line. So that is where our function is convex. Now make sure you indicate clearly what your calculation belongs to. Here we can clearly see that this is where the function is convex because that's the section you're working under. Now where the function is concave, so where f double prime smaller than equal to 0, and we can tell that straight from the graph. That has to happen on this part, right where the parabola dips below the line. So we know that is the interval minus square root 2 over 3 to positive square root 2 over 3. So to recap, when you are asked a question, make sure that you give all justification for your answers and you give all the information asked for in the question. To determine a stationary point doesn't just mean to find its x value, it means finding its y value and determining what kind of stationary point it is. When you find the inflection points, make sure you show all your calculations. When you find convexity, concavity, make sure that whoever marks your paper can see exactly how you have reached the conclusion that you have.